Hello. Now we want to find an expression of energy stored in an inductor. Now we want to find an expression of energy stored in an inductor. When current through the inductor increases, current through this coil increases, magnetic field around it increases. As a result, magnetic flux linked with the coil increases. As a result, an EMF is induced, and induced current try to oppose the basic cause which produces it. Similarly, when current through the circuit decreases, magnetic field around the coil decreases. Magnetic field around the coil decreases. Therefore, magnetic flux decreases. Again an EMF is induced. This time, induced current try to increase the decreasing main current according to Lenz's law. That means that when current through this coil changes, induced current opposes that change in the main current. When current through the coil changes, induced current try to oppose the change of main current in the circuit. If main current increases, induced current opposes the increasing current. When main current decreases, induced current flows in the same direction as that of decreasing current, so that current in the circuit does not decrease. That means that this external current always has to do work against the direction of induced current. This means that this external current has to do electrical work against the direction of induced current. This work done stored in the system as its magnetic energy. When current through a closed coil changes, an induced current flows through the circuit which opposes the changing external current in the circuit. Whenever current through a closed coil changes, an induced current flows through the circuit which opposes the changing external current in the circuit. Thus, to maintain current in the circuit, work has to be done against the induced current. This work done stored in the system as its magnetic. This work done stored in the magnetic field of the inductor as potential energy. This work done gets stored in the magnetic field of the inductor as its potential energy. Now, what is the induced EMF? Minus L di by dt. Minus L di by dt. So this is the induced EMF. This is the EMF of the external battery. They are opposite to each other. That is why this negative sign comes. This is the induced EMF. Induced EMF here. Induced EMF here is minus L di by dt. What is small e? Small e is the voltage of this battery. Induced EMF and battery voltage, they are opposite to each other, therefore this negative sign. So ultimately E is equal to L di by dt. What is power? What is power? Power means current into voltage. Current is I. What is voltage? This is the voltage, L di by dt. What is called power? Power is the rate of doing work, dW by dt. So what is dW? L I di. dt get cancelled. Ako moi koisu, what is induced EMF? Minus L di by dt. So this is the induced EMF. This is the potential difference across the external battery, or this is the EMF of the external battery. This is the EMF of the battery. This is the induced EMF. This negative sign implies that they are opposite to each other. Minus minus plus. What is power? Power means current into voltage. What is voltage? L into di by dt. What is current? I. Power can be written as dw by dt. Rate of doing work is called power. dt get cancelled, so dw is this. Now we integrate current in the external circuit increases from 0 to I0. So therefore work done 0 to W. What is integration of I into di? It is I square by 2. Put the limit 0 to I0. Okay, therefore W is equal to half Li square. What is L? Coefficient of self-induction of the coil. This work done gets stored in the magnetic field of the inductor. What is energy density of inductor? The potential energy stored per unit volume of the inductor is called energy density. It is denoted by small ub. Half Li square is the potential energy in the magnetic field of the inductor. What is volume of the inductor? Cross-sectional area into length. What is volume of this coil? Cross-sectional area multiplied by length of the coil gives you the volume of the cylinder. It is a cylindrical coil. So therefore volume of cylinder is cross-sectional area into length. A into length. What is L? আমি অলপতে ওলাইছিলোঁ μ0 n square small l a. μ0 n square small l a. This is the expression of coefficient of self-induction of a coil. Can you remember it? We derived it here. L is μ0 n square L A. μ0 n square L A. So we substitute the value of capital L here. This A get cancelled. This small l get cancelled. We are getting this. Okay. What is capital B? μ0 Ni. Capital B is the magnetic field produced around the axis of the coil. When current I passes through this coil, a magnetic field is produced around it. What is the value of magnetic field along the axis of this coil? This magnetic field is called B is μ0 Ni. So what is Ni? B by μ0. Therefore n square I square is B square by μ0 square. So I substitute instead of n square I square B by μ0 whole square. So therefore half B square by twice μ0. Therefore half B square by twice μ0. That means magnetic energy density is B square by twice μ0. Can you remember? Electrostatic energy density that gets stored in the electric field of the capacitor. Electrostatic energy density that's stored in the electric field of the capacitor is half epsilon 0 E square. It is derived in the chapter electrostatics called the capacitor. Capacitor বুলি যিটো চেপ্টাৰ আছিল তাত আমি ক্যালকুলেট কৰিছিলোঁ half epsilon 0 E square. When we add this energy plus this energy, we get the energy density of electromagnetic wave. What is electromagnetic wave? Can you remember? Light is an electromagnetic wave. How the light carry energy from one place to other, from sun to the earth. In a light wave, some part of energy is carried by electric field and some part is carried by magnetic field. This is the energy density of magnetic field and this is the energy density of the electric field. Okay? Hello? We want to find out an expression of coefficient of self-induction for a particular coil. For a coil, what is the value of coefficient of self-induction? Actually, value of coefficient of self-induction of a coil depends on dimension of the coil. It depends on dimension of the coil. What is the cross-sectional area of the coil? It is capital A. Capital N, total number of turns of the coil. 1, 2, 3, 4, 5, 6, 7, 8 like this. Small n is number of turns per unit length of the coil. So therefore capital N is equal to small n into small n. Small n is the number of turns per unit length. This is the length of the coil. Therefore total number of turns of the coil capital N is small n into small n. Now when current I passes through the coil, a magnetic field is produced around it. B is mu 0 Ni. When current passes through the coil, a magnetic field is produced around it. So therefore, this is the value of magnetic field produced in this coil when current I passes through. So what is magnetic flux linked to it one turn of the coil? Magnetic flux linked to it one turn of the coil is AB. How many turns are there? Capital N turns are there. So therefore total magnetic flux linked to it, the entire coil is NAB. Okay? That means how many areas are there? 1, 2, 3, 4, 5, 6. Because through every area lines of force passes. Therefore total flux is NAB. So substitute the value of B here. I substitute the value of B. Have you seen it? We substitute the value of B. So what is small n? Capital N by L. Small n is number of turns per unit length. It is total capital N by L. We get this. Now this n and this n get multiplied. So we are getting this. Clear? So phi is equal to, what is phi? Phi is equal to Li. Phi is equal to Li from definition of coefficient of self-induction. L is called coefficient of self-induction. So Li is equal to, so I get cancelled. What we get? L is mu 0 n square A by L. What is mu 0? Permeability of free space. Capital N, total number of turns of the coil. Capital A, cross-sectional area of the coil. Cross-sectional area of the coil. And small l, length of the coil. So if you substitute capital N as small l, then what happens? Small n square, small l square, 1l get cancelled. But this is coefficient of self-induction of a coil in terms of total number of turns. This is coefficient of self-induction of coil in terms of number of turns per unit length. From this equation, it is clear that when cross-sectional area of the coil increases, coefficient of self-induction of the coil increases. When total number of turns of the coil increases, coefficient of self-induction of the coil increases. And when length of the coil decreases, coefficient of self-induction of the coil increases. That means coefficient of self-induction of a coil increases with increasing cross-sectional area, increases with increasing total number of turns as a square, and coefficient of self-induction of a coil increases when length of the coil decreases. That means if length of the coil decreases, then what happens? Turns comes very close to each other. L to যদি decrease হয়, coil to কি হ'ব? Compact হ'ব. ওচৰা ওচৰিকৈ থাকিব turn বিলাক. So coefficient of self induction to কি হ'ব? বেছি হ'ব. Is it clear?